Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And in studio with us we have Amirah. Amirah, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357 and anywhere else 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
Nicely done. Smoothly done also. Felt pretty good with that?
Yeah.
A lot of sixes up there too, aren't there?
Yeah.
You're almost in 6th grade, aren't you? Mm-hmm. What grade are you in?
5th.
Where do you go to school?
Kendrick Elementary.
How is it over there?
It's good.
I'm going to think for a moment. Kendrick must be like cougars or cats or something. What is your mascot?
A cougar.
A cougar. All right, so I was correct on the first guess. And I guess cougar is a cat anyway, right?
Yeah.
So have you been at Kendrick for a long time?
I've been at Kendrick since kindergarten.
Oh, so you like it?
Yeah.
Stuck it out a little bit, huh?
Yeah.
How long will you be at Kendrick? Is this the last grade they have there, or do they have more?
Yeah, it only goes to 5th grade.
It only goes to 5th grade. So you're at the top of the school right now.
Mm-hmm.
What is the best thing, since you've been there for so long, what is the best thing about Kendrick School?
Well, the teachers are really good, but my favorite part is probably the after-school program.
And what do you do during the after-school program?
We have PE and we eat snack, and then we have enrichment, which is basically like a craft, and then homework.
Okay. Nothing wrong with getting a little snack after school either, is there? That's pretty good. Do a little PE, run around a little bit, do some things like that. Do you have a favorite activity for PE or a favorite sport you like to participate in?
Well, we play kickball a lot and after school, and it's really fun. And also, there's cheerleading. I'm in cheerleading after
Oh,
school.
good. All right. So is that something you think you might continue as you go on to middle school?
Maybe, I don't know.
All right. There would be a lot of different opportunities for you in middle school. All right. So, you ready to do some math today?
Yeah.
All right, well, hold your horses because we're not going to get going yet. All right, we have a couple other things to do first. First, a reminder that today is the final day, December 14th, that you can phone in to do the math. And if we do one of your math problems, you will win yourself a pass to Holiday Lights at Com. So today is the final day. You actually have 26 and a half minutes left to phone in and win yourself a pass courtesy of Holiday Lights at Com. Time out for today's Math in the News. All right, today's Math in the News has to do with do you like music?
Yes.
What kind of music do you like? Or do you like all music, or is there a certain type that you like? Or artist or band?
I like all music, basically.
Good, well that's an open way to look at things. You like all music. I like a lot of music also, different types and stuff like that. What kind of music do you think Cece listens to mostly? Do you think it's like the big band era from the 30s and 40s?
That is my era. No, not quite that.
Or country, or rock and roll, or jazz, or what do you think?
Maybe jazz or country.
Or maybe rap could be too, right?
Jazz or country, definitely.
Ask her what kind she likes.
Definitely not country. Anything but country.
Ooh, anything but country here in Bakersfield. Huh?
No,
All right.
I know, and my dad's a rancher. Like, this is a problem, but it's okay.
So
It's
do you have a
okay.
favorite type of music you like to listen to? Or do you just kind of like Amirah,
Yeah,
like to listen to
I'm
it
all over the place.
All right. So have you ever heard of Adele?
Yes.
You have? All right, well, let's take a look right here. So Adele has released 4 albums in total. They were titled 19, 21, 25, and the latest one is titled 30. Were you aware of all those numbers?
No.
Well, that's why she's on Math in the News today, because that last one that came out recently was entitled 30. So the numbers are with Adele's age upon beginning each of those albums, all right? So an integer sequence, do you know what integers are?
I feel like I've heard of it before, but I forgot the definition.
That's okay, that's why we're gonna go through this, all right? And do you know what a sequence is?
Yeah.
What is a sequence?
Like a sequence is like there's one thing and then like it keeps going, things that are similar to it, like a sequence of things.
Good, can you give me any examples? Can you do a sequence of numbers?
Yeah.
Like what?
2, 4, 6,
There you
8,
go.
10.
So you've got it. All right. So it can be defined explicitly by giving a formula for its nth term, or implicitly by giving a relationship between its terms. So we can see Adele's albums go 19, 21, 25, 30. So if we had those numbers and we have them in order, 19, 21, 25, 30, do you see any logical sequence in how that's going? Because from 19 to 21, how do we get there?
Add 2.
Add 2. So then we go from 21 to 25, what do we do?
Add 4.
Add 4. So we add 2, we add 4. What do you think the next one should be?
For 30, add 5.
But first, what do you think it should be? If we add 2 and then we add 4, what
Oh, 6.
6, right? Or we could add 8, like double it every time, right? But she goes 19, 21, 25, and then 30. That's a little odd, isn't it?
Yeah.
But I guess maybe she couldn't wait until she was 31 to start the other album. But regardless, we move on and we'll take a look at different integer sequences, okay? Have you ever heard of Fibonacci?
No.
The Fibonacci sequence, well, big day for you now, right? Because you're gonna learn about Fibonacci, okay? So you start with 0 and 1, and then you add the 2 consecutive terms to get to the next term. So we can see right here, we have 0 and 1. If you take 0 and 1 and add it, what do you get?
1.
1, so that's where we get 1. So now we take the 2 last terms, 1 and 1, we get
2.
2. We take 1 and 2, we get
3.
2 and 3 makes,
5.
you see how this goes?
Yeah.
So taking a look as we get down the line, we'll see if you can do this one in your head. If we take 34 and 55 and add those together, what would come next? So what's 30 and 50?
79.
Almost. What's 30 and 50?
80.
80. And then 4 and 5 is?
9.
So it's 89.
Oh.
Right, there you go. So 79 was close, but 89 is the answer on that one. So the Adele sequence, right? Fibonacci sequence is rather famous. Now we're going to take a look at the Adele sequence. Did she have a particular sequence in mind? So what do you think? Did she have something in mind, or is this just a random sequence?
I think it might be random.
It just looks like a random sequence, doesn't it?
Yeah.
But now you know what an integer sequence is, and you know about Fibonacci.
Yeah.
And that is today's Math in the News. And speaking of Math in the News, we have a little bonus Math in the News. This is actually pretty cool. Let's take a look at the clip very quickly. Did you know there was a best mechanical pencil for math?
Ooh,
No, I
that.
didn't.
wanna hear about
Here it
this.
is, right here. The best mechanical pencil for math lets you write intricate equations clearly and precisely. So you know how you were talking about the graphite
Yes.
being thin and breaking?
Yeah.
This is made specifically for that. So we were talking about the best pencils, and we were talking about different types of
So the
pencils,
lead
number 2s
doesn't
and things like
break.
that, right? So the graphite in the pencil is not supposed to break as easily.
I got you.
Okay.
All right.
And it was this pencil that was made, and we talked about it, and it was something that I had never seen before. But Owen, the student, remembered the pencil, and I guess he and his parents must have gone online, Amazon or something, because I can't read the directions on this also, because it is another language I'm not familiar with. But they found the pencil. And he brought it to me at school the other day and said, hey, here's that pencil that we were talking about on Math in the News that day. So I was like, dude, that's awesome. I can't believe that you even found that. But this is the pencil. I've got it right here. It's a lovely looking pencil, isn't it?
Yeah.
It's sharp looking, right? So we'll,
I was waiting for it to break, but it came through.
Look at that, right? So, thank you to Owen. That is a wonderful gesture on your part right there. A big thank you once again. That was Owen, and there we go. That graphite's not going to break either right there. Hey, all those pencils coming at you. Oh, dangerous. Don't be throwing pencils around, stuff like that.
So I have to go back to the Fibonacci for just a moment.
Okay.
Because I think it was 2 weeks ago, it was National Fibonacci Day.
Correct.
So I just want to throw that out there. And it is what helps us to see a lot of things in nature and beauty and...
Right, and I could have gone off on that.
Oh,
and we
yeah,
could
for
still
sure.
be
No,
doing math in the news for another 10 minutes.
If you're interested in that sequence, go look it up. It's fascinating. So.
You know what? Special guest in studio with us today.
Yes.
We have Amirah, a 5th grade student from Kendrick, and we also have the Colonel.
Oh.
Colonel, come on in real quick. Just come on in here real quick. We're not going to mic you up or anything like that, but let's bring you in real quick.
Hi,
And you know what?
Good.
I'm Steve.
That's Steve. He's the Colonel.
Yes, sir.
Have you ever been to CALM?
Yeah.
You have?
You
Have
ever
you
been
ever
on
seen
the train?
Possibly. I don't remember though.
Okay.
All right, so I'm just kind of, so they can hear you through my mic a little bit right
Okay.
there. So,
Is this better?
that's my ear, brother. Not that. Okay. So anyway, Holiday Lights at CALM is going like gangbusters right now.
Mm-hmm.
So how long will that be going until?
December 31st, last day, and then the next day we're doing a bike through. So on
Oh, all right. I didn't know about that.
New Year's Day. Yeah. So for people that want to bike through Bike Bakersfield, they'll be able to do that.
And what time is that happening?
Same time, 5:30. I
Okay.
believe 5:30 or 6, and they'll ride through. It'll be beautiful.
Oh, great. Well, I'm glad you stopped by, Colonel.
Thank you for
You
having
want,
me.
you want to
See
do a
later.
math, or should we make Amirah do it?
Let's make Amirah do it.
All right.
She's much better at it.
All right. Thanks for coming in, Steve. All right, Amirah, you ready to get to work?
Yeah.
All right, quickly, head on over to the board, and we're going to have one of your math problems put up here, and we'll
You
select
can go
a good
ahead
one.
and grab a pen.
So, Amirah, I don't want you to look at any of these.
Okay.
Choose a number between 3 and 10.
7.
7. So let's take a look at number 7.
Okay.
We'll zoom in on that. So it says 7/15. So let's go ahead and write it up there. 7/15 plus 6/10. And what they want you to do is they want you to estimate this. So explain to Cece, because there's a lot of different ways to estimate, explain to her what you're doing in class.
So what we did for this is so either we could round it to 0, 1/2, or 1 whole.
Okay, so those are our options, are 0, 1/2, and a whole.
Yeah.
Okay, so these are our options. I'm just going to write them up here so we can remember. Okay, good.
So for 6/10, since half of 10/10 is 5/10, we would round this to 1/2 instead of 1 because it's only 1 away and 1 is 4 away. So
Okay.
we would round this to 1/2. And half of 15 is like, 15 is an uneven number.
Right.
So like 10, to be around 7 and a half.
7.5, yeah, I'm exactly right. Yeah, that's exactly right.
So this would be rounded to 1/2 too because it's closer to 1/2. And then we would add them and then it equals 1 whole.
Good, so that's estimating.
Yeah.
Nicely done, I like it. Excellent.
So you
Okay.
feel pretty good about that?
Yeah.
All right. So a little bit later on in the show, we're going to have you working with some other fractions instead of estimating, actually figuring out and evaluating those. All right?
Okay.
636-4357 is the phone number. We do have phone tutors available until 5:30. Once again, today, December 14th, is the final day you can call in to get yourself a pass to Holiday Lights. Speaking of Holiday Lights, let's go check them out.
Today we are at CALM, Holiday Lights, and I am with Megan, the director here at CALM. How are you doing today?
I'm doing great. How are you?
Great. Can you tell us what year is this for the Holiday Lights?
So this is our 20th year of Holiday Lights.
20th year, that's a
Yes.
huge anniversary.
It absolutely is.
Can you kind of give us a little history on how it all began?
Sure, so it all happened before my time, but Josh Barnett used to put these shows on in his family's yard. And then every year it got bigger and bigger. And then as it grew, one of our founders, Stan Eschner, approached him and said, hey, can we do this show at CALM? And that is how Holiday Lights was born 20 years ago.
And I know every year there's something new added on.
Yes.
And we are actually standing in the parking lot, correct? which 2020 when it became a drive-through.
Yeah, so it was the drive-through format of Holiday Lights was born out of the pandemic. However, we've gotten rave reviews to keep it as a drive-through. So we are now coming back with our 3rd year as a drive-through format for the Holiday Lights portion. And then for fun, we brought in a walkthrough option for autumn nights this past fall. So now guests have the option in the fall to do a walkthrough or in the winter to do a drive-through.
Does this, because I'm like looking at this and just the parking lot alone, it is really massive. Has this allowed to have even more bigger and lights brought in?
Absolutely it has. So the course itself is over a mile of inner looping and winding different things. As we go through, you'll see that there are huge light tunnels that we couldn't have inside, as well as a big volcano, larger displays, several different options that we were able to bring out here because we could go bigger.
What out of these lights are the originals from 20 years ago? Do you have any of those?
Oh my goodness, I don't. Sorry, I don't know. I know there are some fan favorites. I think the peacock is one of them, the peacock that's behind us. And then we have several different, like the Yeti is one, and as well as some of the tunnel pieces. We've expanded upon those, but there were walk-in tunnels.
I know this is one of my favorites, and I remember, I think it was over by the bridge and all that.
Yes, over at the waterfowl side.
Yes, and that definitely has always been one of my favorites. Okay, well there is so much more here to look at, but we are going to shoot back to the studio, and when we come back, we're going to look at more of Holiday Lights at Calm.
And once again, if you have an opportunity to go out to Holiday Lights at Calm, I thoroughly encourage you to go do that. And if you'd like to go for free, all you have to do is give us a call here at Do the Math between now and the end of the program at 5:30. On social media, we have a problem of the day, and we'd like to thank all of the people that have been participating in this the last couple of days, since it is a new feature for us on Do the Math and the social media that we have. Let's take a look at the problem right now. All right, so ladies, go ahead. Cece, maybe you'll start writing this. -6, open parentheses, s plus 6, close parentheses, plus 10, is equal to -8s plus 6. And we have some options down there that people have, but you're just going to go ahead and work through the problem with Amirah. Okay. And Amirah, do you have any idea how to solve this type of problem?
No.
Excellent. Yet another big thing for you to do this afternoon. You're going to work with Cece to solve this problem. All right, go ahead.
Okay, so why in the world do we have S's in this?
Maybe we have to like find the number that goes in a place.
You're exactly right. We need to figure out what S is. Okay, so you got that. That's fantastic. Okay, have you ever you've worked with parentheses before?
Yeah.
Okay, so we know that traditionally we would need to add these together first and then multiply by the -6, right?
Yeah.
How do I add S and 6 when I don't know what S is?
Maybe like look at the answer maybe to see maybe.
Yeah, if I knew what the answer was, that'd be great. And actually, what's awesome about multiple choice, if I'm giving you a little tip for taking tests sometimes, if you get lost when you want to check it, you can always substitute back in and see. But we're not going to do that today because we know what we're doing. And we're going to say this. I'm going to show you something really quickly. Sorry, I'm going to kind of go off track for just a moment. If I had this, tell me what I would do.
So you'd add 3 plus 1 first.
Okay. I would get
4.
Fabulous. And then this means what?
Multiply.
And which would give me?
4 times 2 is 8.
Okay. So now I'm going to do what's called distribution. I'm saying this 2 needs to multiply to both of these things. So I'm going to take the 2 and I'm going to multiply it to the 1. What do I get? 2 times 1?
2.
Then I'm going to say, okay, the 2's on the outside, so I need to also multiply it to the 3. What do I get?
6.
What do I get?
8.
Fabulous. See how that works? So that's that's distribution, right? Pretty cool, yeah? Okay, so we're going to do the same thing here. Since we don't know what S is, I'm going to take -6 and I'm going to multiply it to S. Do we know what -6 times S is?
No.
No, we have no idea. Except that I know that it's -6 times S. That's all I know. All right, I'm going to take the -6, I'm going to multiply it to a +6, and I'm going to get?
-36.
Nicely done. You've done some negatives, yeah?
Well, hold on there, sister. She said
Oh,
-36, but you
I
wrote
got
positive.
excited. I got
There you
excited.
go.
You're right. You're right.
I was impressed that
I know.
She got the negative.
I kind of got a little. Yeah. Sorry. My bad. Okay. So we're just going to go ahead and I'm going to bring down that 10 because that's not being multiplied to the negative 6. It's just kind of off on itself. Okay, and we're going to go this, s plus 6. Okay, there we go. All right, now, is there anything I can combine at this point, you think? I say combine, I can simplify.
Maybe like the -6, because doesn't S mean?
So we still don't know what the S is, so I'm not going to be able to pull it together with these because I don't know what this is. But I do know what these two things are. It's a -36 and a +10. Do you have any idea what -36 plus 10 is?
Maybe. Is it still going to be negative?
It is going to still be negative.
Oh.
Why?
Because I think when you have a negative plus a positive, I think it's still negative.
Sometimes. So it depends on, you're kind of like looking at this number line. I'm way down here at -36, and I'm going to go positive in the 10 direction. Where does that land me if I go positive in the 10 direction from -36?
Maybe -46.
Ah, -46 would be more negative. I'm starting to get a little bit more towards positive, right?
-26.
-26, that's fabulous. Okay, so this is -26. I still have this -6s. Now I have the -26 is equal to -8s plus 6. Now this one, I'm not sure if you've seen this one before. Okay, now I have s's on this side, I have s's on this side, I have -26 on this side, I have 6 on this side. I kind of need to start really figuring out how to like rearrange this stuff, right? So I'm going to basically remember that an equation, my equal sign, is a balance. So what I do on one side of that equal sign, I have to do on the other side of the equal sign, okay? So I'm going to, how am I going to get, I say get rid of, eliminate. How do I get rid of, ooh, I guess I can move it with my finger. Oh, that was magic. That was like seriously magic right there. Okay.
Here, I'll move that. Hold on a second, so
Okay.
you get rid of all those marks. There you go.
Okay, thank you. All right, how do I undo or get rid of a -6s? What would take it to 0? If I'm thinking about this.
Add a negative to it.
Okay, so if I'm
Or
at
add a positive.
-6, how far do I need to go up to get to 0?
-4, no.
So I'm at -6, and I'm going to go up to -5, -4, -3, -2, -1, then I get to 0.
5, no, yeah, no, 6.
I'm going to go +6 because look, -6 plus 6 lands me at where?
1.
It's going to get me to 0, right?
Yeah,
-6 plus 6 is going to get me to 0. So that's going to be 0 s's. What's 0 times anything?
0.
0, right? So that's how I eliminate it, right? So I can get that to 0, but guess what? Remember what I just said? That if I did something to one side, I have to do it to the other side. I've got to keep this balance. So I'm going to add 6s because that's what I did over here. It was nice and inconvenient. I probably should have added my 8, but that's okay.
I was going to ask if you wanted to get rid of the smaller x, and a lot of students will do what you did. They'll go, well, the
But it doesn't
smaller is
matter.
6,
Right.
as long as you are cool with your negatives at the end.
Exactly. So we're going to say we're cool with negatives because you have nailed it so far. I'm really impressed. So we're going to say we're cool. All right. So -8 plus 6, what do you think? Do you think it's going to be negative or positive?
If maybe positive.
So we're saying we're starting at, so we'll keep kind of go back to this again. So if I'm at -8 and I'm going to add 6, I'm going to go in the +6. 1, 2, 3, 4, 5, 6. Where is that? Where am I now? So this would be -7, -6,
-2.
-2. She's so good. -2s, and I'm going to go ahead and I'm going to, for right now, I'm going to keep that +6. Okay, so now I'm saying I've got all my s's on this side. So now my s's are on this side. I need to get, my answer is supposed to look like this. 1s is equal to some number. That's what I'm looking for, right? So if my s's are on this side, I want to get everything away from my s's. So I have 1s all by itself. So we're going to go ahead and we're going to do this. How do I undo, get rid of a +6?
Subtract +6.
I'm going to subtract, okay, subtract +6 or just subtract 6. Subtract 6. I have -2s. I'm going to run out of room. I'm at -26, so I'm here. I'm subtracting 6, so now I'm going to go this way. So 26, 27,
28, 29.
So what do you think negative 26 minus 6 is going to end up with?
Negative 20. Or,
Oh, that's if I was going to add it.
oh, wait, negative.
But I'm going this way. I'm getting more and more negative. How far negative am I going?
Negative 32.
She's so good. Okay, fabulous. Now our last thing, remember what was this? What's this relationship? Is that addition, subtraction, multiplication, division? What is that?
I think it might be multiplication.
It is multiplication. And I'm going to say, look at how when it was addition, we subtracted. When it was subtraction, we added. What undoes? What kind of I guess we'll just leave it at that for now. There's more technical terms. But how do we get rid of, undo, get to 1, this negative 2? If it's multiplication, what kind of undoes multiplication?
Division.
She's so good. Okay, I'm going to divide by negative 2. Because negative 2 divided by negative 2 is? Don't overthink it.
1.
1. And remember we said our goal was to get 1s. What I do to one side, I must do to the other to keep that balanced. What's 32 divided by 2?
16.
Oh, wow. And negative divided by negative is a positive. There we are. S is equal to 16.
All right, nicely done. So 16 is the correct answer. And for all of you that did that on social media, thank you for that. If you got it correct, even better right there. As a reminder, today is the final day. You've got about 30 minutes left to phone in to do the math. We'll take a look at the phone tutor room right now. And we can see that we have a couple of people online right now. There they are. There's Aaron. You know what? That's funny. There's Aaron and Aaron. Okay, so they're both on ducking. And give us a call until 5:30 this afternoon. You can win yourself a pass to Holiday Lights at Con. All right, Amirah, are you ready?
Yeah.
All right, let's go and take a look at another problem that you have. We have 7 over 8.
Okay, I'm going to let you come maybe over a little. Yeah, there you go.
Minus 5/6. Now this one, we're not going to estimate. You're actually going to do this problem. So you're going to learn about least common denominators and the next thing that's coming up in class. Okay, so Cece's going to help you out.
Okay, have you done least common denominators?
Yes.
Oh, fantastic. Okay, talk me through it.
So what my teacher told me is we do 8 and then 6, 8, 16, 24, 32. I'm
Okay.
just going to do 4.
Okay.
6, 12, 18, 24.
Okay.
And the least one is 24.
Excellent.
So we're going to use 24 as our new denominator. So to get 24, you have to multiply 6 times 4, and then whatever you do to the denominator, you have to do to the numerator. So that would equal 20 24ths. And then times 3 times 3, that'd be 21 24ths. And if we add them together,
It was subtraction.
oh,
yes?
subtraction.
Okay.
Correct.
See, it's not just me. Although maybe I'm just rubbing off on you. I'm sorry.
So 21 minus 20 is 1, and then the denominator stays the same.
Fabulous.
All right, so here's what I'm going to do. Today, I told you about my new pencil that is proven to do mathematics beautifully. I'm going to take my pencil, put it in my pocket, and I'm going to walk off set because Amirah now has done all of the problem on her own right there.
I know. I was pretty much ready to just be like, I'm out. See
How
ya.
you feeling, Amirah? Pretty good?
Yeah.
That was a pretty easy problem, wasn't it, for you?
Yeah.
Oh, good. So I'm going to come up with a more difficult one for you in a little bit. But first, we're going to head, you know what? For doing a great problem, before we even go out to Holiday Lights to Come, I want to give you a meal courtesy of our friends at the Broken Yolk Cafe. So congratulations on that.
Thank you.
Have you been to the Broken Yolk Cafe?
Yeah,
For breakfast or lunch?
breakfast.
And what is your favorite thing over there? Is there something you like to get over there?
Yeah, I think one time I got their chicken because I'm not a breakfast person.
All right. Well, good. Well, you know what?
Hurtful.
As long as you can get whatever you like, all right? So when you go over to Broken Yolk, tell them you want to do the math and they'll set you up. Sound good?
Chicken and waffles.
Yeah.
Do the chicken with that's okay.
Ah,
Just making sure. Just making sure.
Getting the old man hungry right now. It's almost dinner time. Past my dinner time. Anyway, we'll be back with more right after this. We'll check out more Holiday Lights, see what Marylou's up to.
We are back at Holiday Lights at Com with Megan, and this is another one of my favorites, is the tunnel. It is just so amazing. when we used to do the walkthrough, you just had that small tunnel, right? And now look at it.
You have a massive 300-foot tunnel that grows every single year. It acts essentially as a time warp as you go through and end up in our prehistoric land.
So there, everyone's coming this way.
Yes, ma'am.
Oh, wow. So you talked about the autumn nights. How much of the autumn nights is involved with the same lights here?
Yeah, there's a lot of crossover. So while we were finishing up the build on autumn nights, we were working on the build for the drive-through holiday lights. And then when autumn nights was down for the last night, we had a 3-week turnaround time to get a bunch of lights from there back out here.
So when do you start with this? When does everything start being placed?
For building, we start as early as August. So we have several months of build.
When does the planning though?
Planning, honestly, is nonstop, but we start our conversations usually in February each year of what are we bringing this year, what needs to change from last year, how do we want to make things bigger and better, but that usually starts in February.
So there's obviously a lot of cars that are coming through here. What approximate every night, what is your average for the amount of cars coming through?
So we average on sellout nights about 800 cars per night. Last year we saw over 25,000 cars through the show. So 25,000 families and groups of friends that got to enjoy the show itself. The first couple of weeks are our building weeks. People are getting into the season, and then once December hits, it is full holiday season, and we usually sell out every night.
When does it all end?
Our last night is December 31st as a drive-through, and then on January 1st we have a Bike Through the Lights event.
Is there anything that, like you said with the planning stage, that you've looked back on the last 2 years and said, okay, for the cars, the way they move through here, this needs to change?
We've made some adjustments talking to the Light Tasmic team. There's always some areas where you've got kind of stand lights that tend to get knocked down, and so we made some adjustments, made some areas wider, things like that. And then we change up the areas every year so that you're experiencing a different show.
And you talk about the tickets, about selling out. Where do people go to purchase tickets? Can they just line up? Because I think they do line up off of Alfred Harrell, is that correct?
So it's Lake Ming and Alfred Harrell. The line starts at Lake Ming and then we take a back road up into Calm. Tickets are on sale at calmzoo.org. We tell everybody to buy your tickets online ahead of time. It is cheaper. It's $30 online. If you purchase at the gate, it's $40, and those are not guaranteed because our goal is to make sure that our wait times aren't too long. So we cap out at a certain number each night.
And how many approximate cars do you have actually going through here, not waiting, but at one time? How many are
roughly
within?
I want to say about 100 to 150 cars that can be in the show at the same time. The show itself takes about 30 minutes to meander through, but it's a constant steady flow. Our wait times on the busy nights can average an hour to an hour and a half to get into the show, but the show itself is about 30 minutes.
Well, it is absolutely fantastic out here, but we have more to see, so we are going to shoot back to the studio and we'll see you back here in a minute.
And spectacular sight right there. If you've never been live out at Holiday Lights at Calm, as the Colonel said, you have until December 31st to go out and enjoy those lights, and the next day, a little bike through, as they were just talking about right there with Marylou. We do have phone tutors available until 5:30 this afternoon. We have Amirah, a 5th grade student from Kendrick, who loves everything about Kendrick, especially the after-school programs.
Yeah.
All right, good. Are you ready for a little different type of a problem?
Okay.
So select a number between 1 and 8, and we'll see which one you're going to be doing here.
2.
2. All right, let's find out where number 2 is. Here we go. So you and Marylou are going to work on this together. You can write it up on the...
That's not...
Marylou was just at Holiday Lights. Cece's like, listen, old man, I know who I am, I don't know who you Yeah, all right, I'll take that one buzzer. And I think, you know what, honestly, I think in the last 21 plus years, maybe the first time I've done that. First time.
Oh!
Easy on that. Whoa, easy. I don't need to see pull-up of past shows where I've done that, so let's move on. All right, ladies, over to the board. So you need to know a little vocabulary, Amirah. So the first thing says the sum. Do you know what the sum means?
Yeah. It's the answer to an addition problem.
All right. So the sum of the digits is 10. Their difference is 2. I'm less than 50. who am I? So how do you want to go about this? You've got Cece to help you out.
What do you think? Do you know what it means by the digits? My digits are?
Yeah.
Okay, so tell me what that means.
The digits are like the numbers in a
Okay,
number.
so if they're supposed to add up to 10,
Right,
the
they
sum
add to 10.
of my digits is 10. So let's, and we know that it's between 0 and 50. So let's kind of maybe think about, I don't know, I haven't seen this problem. So maybe we can think about what some of those numbers might be that add up to 10.
I
The sum of my
kind of think
digits.
I know.
Oh, she thinks she knows.
Because 6 plus 4 is 10, and then 4, 5, 6, that's 2.
What do you mean she got it? I don't see anything on the board except 0 and 50.
Okay, so talk me through how we might set this up. Or you, I am gonna back away from the board. I'm just gonna, you go for it. Tell me some of the other, the digits would add to 10. So let's list out some of the digits that would add to 10.
5 plus 5.
Okay, so 55. Okay, but that one's outside of 50, so we need inside of 50. Other than the one you already gave me, which was, 46. Okay, what else do we got? What if we started from the beginning? We said, okay, 1, so I've got like all of my 11, 12s, 13s. What would it have to be?
1 plus 9.
Okay, so I would have 19. Okay, cool. So how about 2?
2 plus, not time. 2 plus 8.
Okay, so 28. All right, what else? So how about 3?
3 plus 7.
Okay, so 37. And then we said 4 and 6 gives me the 46. Okay, so that's the one you gave me. All right, so let's talk, those are our sum of 10. Now let's talk about their differences. So if I did the difference of the 1 and 9, I would get what?
1 minus 9.
Which is, or 9 minus 1.
8.
Okay, so that one, we'll go, right, okay. So how about this one?
8 minus 2 is 6.
6, so nope.
7 minus 3 is 4.
Yeah, nope.
6 minus 4 is 2.
Ding, ding, a ding, and
There
a
you go,
ding.
nicely done. So you said you were all nervous about doing this type of problem, right? Erase the board, you did that one so well,
Here,
we're
I'll
gonna
do
have you do
this.
another one.
I'm gonna, yeah.
So this one, we'll write 46. There's the answer. So another between 1 and 8, but not number 2.
5.
5. All right, let's find out where 5 is. All right. Ooh, excellent.
Ooh.
The sum of my digits is the same as the product. Who am I?
And it doesn't give us a range, it just is.
Correct.
How do we want to go about this one?
I'm not sure.
So for me, I like to play. I like to just kind of mess around with stuff, right? So you're outside and you kind of want to see if you can tie some sticks together and you just sort of goof around with it until you figure out a way, right?
Yeah.
Okay, that's what I do with math too. Don't tell. That's how I do my math. So for me, I'm going to say, okay, let's just go ahead and kind of play just a little bit and see if we can find a pattern maybe. So if I do say, so let's go back to that first where we said 19. Okay, so if I apply this rule, the sum of my digits is the same as the product of my digits. So 19, I'm going to say the sum of, and then I'm going to do the product, which means?
10.
What? No. What does product mean?
The product is the answer to a multiplication.
Right, so I've got this. Okay, so 1 plus 9 is?
10.
Okay, and 1 times 9 is?
9.
9. Okay, so that definitely doesn't work. What else? What other one do you want to try? Just so we can kind of just play with it just a little bit.
Maybe it can be any number.
Any number. Let's just try. Let's keep it below 50. We'll go with that one for right now and see if we can't kind of see what.
24.
24. Okay, so 24. If I add 2 plus 4, I get.
8.
I don't get 8.
I mean, not 8, 6.
There you go, because you were doing your multiplication. You were one step ahead of me to get to 8, and that should be multiplication. Okay, so that doesn't work. So what we're starting to see here, though, is that I kind of have a blank plus a blank, and then a blank times a blank gives me this, right? Okay, so I'm kind of wondering, I think I know what this is. I think I'm there, because we're talking about And I'll get you there, don't worry. So let's go ahead and try one more. Go ahead and pick just one more.
I don't know. I'm trying to think of like what numbers would equal.
I'm going to give you a little, we'll kind of try this really quickly. I'm going to say, what if these numbers were the same? So I have something plus itself, something times itself, and both of these are the same number, right? Because that's what we're really trying to say. The sum of my digits is the same as my product. So I've got what number, when I add them together, is the same as if I multiply them together? So I could have like maybe 33. So if I do 33, that's 3 plus 3 is 6. 3 times 3 is 9. So that one doesn't quite work. Okay, so
I'm trying to think. I was thinking like something times 11, but I don't think that would, like 55 or something, but I don't know if that would work.
Fascinating that you say that. So let's go ahead, just like you made that list before of the 6 and 8s, right? So we have 11. What are my multiples of 11? I have 11.
22.
22.
33.
33, which I just did, and that one didn't work.
44.
44. We could try this one. You want to try this one?
Yeah.
Okay, so if I do this, 4 plus 4.
8.
8. 4 times 4.
16.
Okay, so that one doesn't quite work. Let's try this one.
Oh, it's that one.
There we go. 2 times 2 gives me 4. That's the magic of our 2s. So the actual answer, though, it says the sum of my digits is the same as the product of my digits. So what is the actual number? Is it 2s? Is it 4s? What is it?
The actual number
Is
22.
Is 22. Nice.
Nicely done. There you go. So I see you're getting even better at these types of problems right now. 636-4357 is the phone number. Today, December 14th, is the final live broadcast day until we come back on January 10th. So we'll be off for a couple of weeks, and keep an eye on all of our social media, because we will have some different things going out there, and a little behind the scenes and a little bios and things like that will be coming out. Is that not correct? There we go. Word official from the producer over there. So look for a lot of things coming out on social media during the couple of weeks during that holiday break. We do have one more opportunity to go check out with Marylou and see what's going on at Holiday Lights.
We are back here at Holiday Lights at COM with Megan. Megan, it has been fantastic just seeing all the lights, and as really the sun is going down, everything is just coming to life, and it's just a great time to be here. But you know, I know that there's a lot going on here, and there's a lot of people behind who put this on. If you want to be a volunteer to help out, because I assume you need a lot of volunteers.
Yes.
How can you be a volunteer?
So if you go to comzoo.org/volunteers, you're going to learn all about how to volunteer for the Holiday Lights show. Ages 16 and up can come be a volunteer. Every night we need about 20 volunteers to help us with ticketing and with traffic flow and all of those things. So that's a good place to sign up to support with your time. The other benefit of that is every night that you sign up, you get a ticket to return to the show that you can either keep yourself or you can gift to somebody else.
And what are those times that you're asking them to help volunteer at?
Volunteers show up about 4:45, and then depending on what station you're at, you're usually out of here by 9:30.
Okay. And then we know, looking around, there's lots of signs, and there's a lot of corporate sponsors and sponsors. And if somebody wants to sponsor, what should they do?
Yeah, so Holiday Lights at COM is a community event. Our goal is to get companies' names out into the community, as well as just really bring families in. So if they want to be a sponsor for the show, they can reach out to me directly for our 2023 show. We've been blessed to be able to have all of our sponsors for this show.
So my big question to you is, now you've done the autumn, you started the autumn nights, yes, right? And obviously this is the 20th year, which is fantastic. Anything in spring? Are you guys thinking of anything in spring?
As far as a light show, no, right now. However, we are going to continue with our Keep Calm Jamboree. So last year, if you missed it, we had Yachtly Crew out here with the partnership with Camp Keep, had a huge concert, and we will be bringing that back again this year. So look for that around Earth Day as another kind of one of our bigger opportunities to come out and one, have some fun, and two, support.
Well, Megan, as always, it's always a pleasure coming out here. And 20 years, that is just amazing that this has been going on for 20 years. And every year it's just getting bigger and more fantastic. So again, it's $30 a car, correct? And then again, one more time, the website to go to purchase your tickets.
calmzoo.org.
And what time does it begin at every night?
Gates open at 5:30 and close at 8:30.
So there you go. Go on out, get your tickets, come on out here. It's absolutely beautiful. And that's it from Calm Holiday Lights. And again, thank you.
Thank you.
And a big thanks to the staff at Holiday Lights and Calm. And a big thanks to the Colonel. He has a lot to do with those Holiday Lights at Calm. And also a thanks to Marylou for heading out there. All of the people behind the scenes filming all of that for some great footage so that you can see almost like being there in person how fantastic those lights are out at Holiday Lights. We do have Amirah, a 5th grade student from Kendrick School, in studio with us. And you have been working with fractions. And you have estimated them. You have added them, and now we're going to start multiplying them, all right? So I would like you to give me any number you like between 1 and 9.
7.
7. So draw a fraction bar up there. Draw a line for a fraction bar up there. So first of all, we have...
0.
Oh, you did a... Okay. So maybe we'll shorten that line a little bit.
Or more.
There you go. Keep going that way, and I'll tell you when to stop.
You just want a fraction.
Right.
As like a he's talking about like a fraction bar.
There you go.
So not a number line. Yeah, there we go.
Okay. And so you can take the ends off of that. So you have 7. So put 7 as the denominator. And we will put 3 as the numerator. So select another number between 1 and 9.
4.
4? All right. So let's make 4. So draw another fraction line. 4 is the denominator. And we'll make 2 the numerator. And now we're going to multiply those. So Cece is going to help you with how to multiply. But before you do, you input, give her any ideas you think on what you might want to do first.
So maybe since like the denominators are different, maybe we change them.
What do you think we might need to change them to?
Like, you know how we did the least common multiple? Maybe like we do that, or like, yeah.
Okay, so the cool thing about fractions, or maybe sometimes I guess students think there's the confusing thing about fractions, is that when we think about adding or subtracting them, have you guys done like pizza, kind of, piece of pizzas? Okay, so if I'm adding a half to a fourth, there's a reason I need to have this. I need to say how many fourths is this. I would break it into that so that I have 2 fourths, and then I could have my 1/4, so that I have something that makes sense into 3/4, right? So that's our addition of fractions, right? Okay, so we've got to have our denominators be the same. With multiplication and division, we don't. Okay, so we don't have to worry about our denominators being the same thing here. So the beautiful thing about multiplication is that we really don't have to change anything. We're just multiplying. But I think what Mike's alluding to is that he's looking at this fraction here. We've got 2 divided by 4. Is there something we can do there? Have you talked about reducing fractions at all?
Yeah.
So how could we reduce that one?
We could divide it by 2/2 to get 1/2.
Right, whatever I do that top, I gotta do to the bottom. So yeah, go ahead and do that, and let's see what our new fraction is. Okay, so our new problem then is 3/7 times 1/2. All right, so now just really quickly, we're just gonna go really quickly. Do we know what this means? Like the other ones we had pizzas and we're like, how many fourths are we doing? What does this even mean?
Like, so it'd be like when you do regular multiplication, like 3 times 2, it's 3 2 times. And like 3 times 2 is 6, and 3 plus 3 is 6.
Yeah.
So that's kind of what like multiplication.
Right, so I'm gonna ignore this 7 for just a brief second, and I'm gonna say 3 times 1/2. Do you know what 3 times 1/2 is?
3/6.
Okay, so I am going to say that just like you said, 3 times 2 is 6 because we have 3 2 times. I'm gonna have 3 1/2 a time. What is 3 1/2 a time?
Like 1.5.
1 1/2, right? What is 1, if I have 1 1/2, I can put that into a mixed number, right? I do the multiplication 1 times 2, gives me 2, plus the 1 more gives me 3/2, right? So my answer is 3/2. Look at this. How do I write 3 as a fraction? I write it as 3/1, 3, 2. We just multiply straight across. So we're going to multiply this straight across. Tell me what you're going to get. So my numerator times my numerator is?
4.
Multiply.
I mean 3.
Yep.
And then 2.
Oh, no. So we're going to multiply. So it multiplies across and multiplies across.
So these 2?
Nope. So we go straight across. 3
Oh.
times 1 gives me 3.
So it'd be these 2?
Aha,
Oh.
straight across.
I thought you said not to
Sorry.
do that.
Nope, we're good. So that's it. That's multiplication of fractions.
Oh.
Yeah, we don't have to change denominators. We don't have to do anything. Now, sometimes we've got some reducing to do. There's a lot of times that we'll have reducing to do, but we don't have to do any common denominators.
So let's try this one quickly. I'll give you guys a minute to do this.
Okay.
So 2/3 times 4/5. We'll just use 2, 3, 4, 5.
Okay, go for it. You're right.
Over 15.
Dun da da da.
How you
Nicely
feeling?
done.
Pretty good with that?
Yeah.
All right, hot shot. Let's try another one.
Now you can. I'm done. I'm walking away.
Okay, so you're in 5th grade, so let's go 5/6. And how many people are in your family?
5.
5? Let's go 2/5. Can you do anything with that? Can you simplify that?
Yeah.
And we're going to have you leave it just like that. Don't do anything with it. All right, we're going to come back to that. But first, we're going to check out latest from NASA.
The International Space Station orbits Earth in the cold, solitary vastness of space. But look closer. There's a cornucopia of species bringing the interior of the station to life, and with it a plethora of scientific knowledge contributing to humans learning not only how to survive in space, but thrive both on Earth and beyond the edge of our planet. Animals that fly in the air, animals that swim, squirt, and float in water, animals that creep, crawl, walk, and run on land, all are being studied to learn how they react and adapt to microgravity conditions. Since many share similar cells, tissues, and other organic structures to humans, each is studied for what they can reveal to help astronauts withstand the rigors of long-range space travel. Some examples. The tardigrade, or water bear, is well known to possess genes that can withstand extreme hot and cold temperatures, dehydration, and radiation. What can we learn from these amazing creatures that might help keep astronauts safer in extreme environments? Astronauts exercise 2 hours a day and closely monitor their diet. However, the loss of muscle mass that occurs in space is still a serious obstacle that researchers are working to overcome. As such, roundworms were exposed to a microscopic obstacle course to study their unusual muscle strength, while zebrafish have helped researchers develop countermeasures for muscle weakness. Another fish, the Japanese Medaka, have helped improve our understanding of the mechanisms behind organ tissue changes. And of course, one of the most common space travelers, the rodent, was found to be more physically active in space than their Earthbound counterparts in one experiment. Why? This matters to scientists who are studying the effect of microgravity on bone loss. Jennifer Buckley is the Deputy Chief Scientist for the International Space Station Program Research Office at NASA's Johnson Space Center. She explains how studying multi-generational organisms can have big impacts on our understanding of both animal and plant biology in space. Fruit flies multiply so quickly, we can observe several generations at one time. We can trace the actual development of an organism from conception to birth to adulthood and old age, and the genetic changes from one generation to another are easy to track. Regarding plants, Buckley says, plants develop differently in microgravity. They don't know which way is down anymore. They no longer have a gravity signal for their root structure. So we examine their RNA to see how it's giving directions and signals, and how that differs from the way plants behave on Earth. Many types of plants are grown on the station, from flowering plants to leafy greens to vegetables. What we learn could influence our approach to growing different plant types in the future. Practical benefits for those on Earth have come from studying all these various forms of life in space. Traditional fertilizer can't be used on plants in space, as they're not grown with traditional soil. As a result, NASA scientists, working closely with the private sector, developed a fertilizer that would release its nutrients over a specific amount of time. The process proved to be not only successful in space, it can also be used on Earth in vertical farms and urban plant factories. Life in space is not new. The study of numerous species going back several decades have given researchers multiple views of how life can exist and thrive in the harsh environment of space. Buckley concludes, we'll conduct hundreds of experiments during each 6-month expedition. We want to study a broad diversity of organisms that will help us travel beyond low Earth orbit, while also giving us insights that may improve life on Earth. For more information about the multitude of life on board the space station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
Always fascinating. Amirah, would you go on the space station if you had the opportunity?
Yeah.
Well, why not, right? It's not that far away, really. So you did simplify that all the way. What was your final answer?
1/3.
And if you looked at 10 over 30, what could you have done really quickly?
Divided it by 10.
Divided by 10. Just take the zeros right off of that. You're all through, right?
Yeah.
All right. Nicely done. Come on over here, young lady. So you have done some excellent work today. You are now our newest ambassador, so come on over here a little bit. We're going to show everybody your new uniform. So this means all you have to do is when you're wearing your shirt to tell people about the show. Can you do that?
Yeah.
All right. I have every belief that you're going to be an awesome ambassador for Do the Math. Did you learn a little something today? I think you did. You got pretty good at it also. Did you have fun today?
Yes.
That's the most important thing right there. Hey, just a reminder, Where in the World is one of the new things we have on social media. Check it out, Where in the World. So if you go someplace, we want to see you with your t-shirt on, your pencil, anything you have from Do the Math, send it to us through social media. We'll recognize you on the show, and who knows, you might get more stuff. Until we meet again next year, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.